The open-build C-beam linear actuators are only available to mount Nema 23 stepper or servo motors. This video will describe the design and production of some Nema 24 mounting plates to enable the mounting of the Nema 24 closed-loop stepper motors onto the open-build C-beam linear actuators. Hello, I'm John Manier from Accu-Slice. Over the past year I've been developing this new automated bandsaw using our Accu-Slice system. This is a system to accurately control the thickness of boards you're cutting and to automatically pass the boards through the bandsaw blade with no operator need to control the pushing the board through the bandsaw blade. Details of this are described in other videos which are posted on our website and are listed on the description of this video. Anyway, this system is using 3 stepper motors, and these are closed-loop stepper motors. 2 for the linear movement of the board into the bandsaw blade to control the thickness of the board being cut, and a third system which drives the board through the bandsaw blade to actually cut it. And on the indexing of the board to move it into the bandsaw blade, I'm using 2 stepper motors in parallel. And I'm using 2 of these because I am pushing a 4-foot long piece of metal to control the accurate, making sure these 2 systems stay perfectly parallel with one another as they drive the board in to get the accurate thickness of the board you want. In this prototype version I used some Nema 23 motors which fit fine on these open-build stepper motor linear actuators. But with the new version I'm making for a customer, I'm changing these to some a little bit larger stepper motors which are Nema 24s. And as a result, the Nema 24s do not fit these open-build linear actuators. So I needed to change this front plate. So this video will describe the design and the machining and the production of these new front plates for these open-build linear actuators. I did the basic pattern designs for the various holes using the SketchUp software. I then refined the design and did the programming for the machining using the Centroid Acorn CNC software for the mill. All machining and milling was done on my CNC converted Precision Matthews CNC mill. In order to reduce the viewing time for this part of the video, I sped up this machining video 5 times the actual milling speed. I first of all began by pre-drilling a hole using a center drill to mark all the holes that will be drilled in the 3.5 inch by 3.5 inch by 1/2 inch thick aluminum plate. I next use a 0.16 inch diameter drill to drill the holes for the center hole and also for the 4 holes which will be used to mount this to the stepper motor. These holes are drilled completely through the 1/2 inch thick aluminum plate. These will later be tapped using a metric 5 tap and will be used to mount the stepper motors to the plate using metric 5 screws. I next use a 0.197 inch diameter drill to drill the 4 holes which will be used to mount this plate to the linear actuator. These holes will be later countersunk on the reverse side of the plate in order to recess the screws to mount this to the linear actuator. I next use an 11mm drill to drill completely through the plate for the linear ball screw. I next needed to countersink the center hole to tightly fit the ball bearing on the open-build linear actuator. This hole is machined using a 3/8 inch end mill to precisely enlarge and countersink this hole to 16mm in diameter and to the same thickness or depth as the original open-build plate. Finally, I needed to reverse this plate upside down so I can countersink the holes on the reverse side to enable the mounting screws to be recessed below the surface of this mounting plate. I use the same 3/8 inch diameter mill to countersink these holes about 1/4 inch deep. And here's the finished plate. See the countersunk hole for the bearing on that side, and then the countersunk holes on this side for the mounting screws. I begin the installation by first removing the 4 screws that hold the end plate on the open-build linear actuator. I install the ball bearing into the recess in the new end plate and then attach the end plate to the linear actuator using the same 4 mounting screws. Notice that the open-build linear actuator is installed upside down in this application. One of the main reasons for this is to keep sawdust from accumulating and contaminating the linear ball screw. The Nema 24 stepper motor with the shaft coupling attached is then attached to the mounting plate using the four 55mm long metric 5 screws and 4 aluminum spacers. The original mounting plate on the open-build linear actuator used 2 screws to mount the stepper motor. One of the main advantages of this new mounting plate is that it uses 4 screws to mount the stepper motor. This should provide for a more stable mounting of the stepper motor, especially considering this increased weight of this larger and heavier stepper motor. Well, this is the final assembly of the system. I have my 2 linear actuators here with my 2 stepper motors mounted, and these are 2 Nema 24 closed-loop stepper motors, and I've adapted my new plates. And the advantage of the system, I'm using 4 standoffs to bolt my stepper motors to my mount, so I like this much better than just using the 2 that are normally done with the open build system. I still have one more stepper motor to hook up, and that's for the linear actuator to drive the board through the bandsaw blade. And this is a Nema 34 motor. I need to make a plate for this, so I have this plate designed. I just have to machine it, so that's my next project, to machine that plate. But these systems are all done here, and these plates worked out quite nicely. They work nice and smoothly. I can move my system in parallel and move it back and forth. These plates, I have custom machined, and they are available, and details on this are available on our website and in the description of this video. In a likewise manner, I machined the adapter plate to mate the Nema 34 stepper motor to the Nema 23 mount on the end of the long linear ball screw on the automated bandsaw table. The machining steps were much like the previous adapter machining, with the exception that I used 6 mill tools to drill and mill the various holes and countersinks in this adapter plate. This section of the video is sped up 20 times the actual cutting speed, again for viewing purposes, just to reduce the viewing time. Here I'm milling the 16mm diameter center hole for the shafts to join between the 2 systems. The stepper motor requires a 1mm deep recess on this mounting plate to accurately mate the stepper motor to the adapter plate. This is the slowest step in the machining operation. We have the capability of machining custom adapter plates for stepper or servo motors. Please contact us for more information. After a quick cleanup, this is the finished adapter plate. I first installed a shaft coupler and then attached the new mounting plate to the existing adapter using 4 of the number 4 metric screws. Notice that all 4 of these screws are recessed into countersink holes in the adapter plate so as not to interfere with the mounting of the stepper motor. The Nema 34 stepper motor is then attached to the adapter plate using 4 1/4 by 20 thread per inch screws. I had previously tapped these 4 holes on a mounting plate using a 1/4 inch by 20 thread per inch tap, which was not shown in this video. This completes the assembly of the 3 stepper motors on the new automated bandsaw table. This is a fully automated system to slice boards repeatedly and accurately on the bandsaw with minimal operator interference. The system is controlled by software to determine the thickness, length, and the number of boards to be sliced. Details are described in a YouTube video series, which is detailed in the description section of this video below. These adapter plates to mate a Nema 24 stepper motor to the open build linear actuator are available as described below and also listed on our website. In addition, we have the capability to custom machine additional adapter plates for stepper or servo motors. Please contact us for more information. Once again, thank you for watching this video. If you have any questions, concerns, or comments, as always, please give us a call or drop us an email. And thank you.